How's everybody doing today? I want to introduce myself. My name is Mr. Cohen, and we're going to be going over SAT math today. So, SAT math can be a bit tricky for some students. So, I really just want to lay out some basic topics, and then we're going to go through some strategies as well, some test taking strategies that are useful for the SAT. So, as we begin, I usually warm up my lessons with a little bit of a bell ringer, which is basically a little review of some topics. So, for instance, I might ask you number one, what is the value of t over 3 minus t over 2 when t equals 36? All right. Now, generally, I would give all 5 of these questions to my students and let you work on them. And then from there, we would go over the answers together because it's important to know what we got right and what we got wrong. I also wanted to mention, as part of my teaching philosophy, my teaching approach, is obviously I'm a very encouraging teacher. You know, I love math. I also do the reading section. I also do the reading and writing section of the SAT. So I like the test. It's kind of fun for me. You know, I have a nerdy side as well, but I think that learning should be fun to some degree, right? I want it to be enjoyable. Like, let's try to get some work done. Let's learn something, but if we can enjoy it in the process, I think we get more out of it. So I might walk through some of these answers. For instance, I'm just getting my pen together. So if t equals 36, this is really just a plug-in. So 36 over 3 minus 36 over 2. 36 divided by 3 is 12. 36 divided by 2 is 18. 12 minus 18 is negative 6. Okay, so this one would be C. So again, it's good, I think, to warm up, right? We always need review. You know, the SAT is comprehensive. It covers multiple topics. So it's always good to review. And I encourage students to ask questions. That's really what these sessions are for. I try to make the sessions really a dialogue. So we'll do a couple of these bell ringers. Which of the following best describes the solutions to the inequality? Negative 6n plus 7 is less than or equal to negative 59. All right, so it's a fairly straightforward inequality. Let's let's subtract 7 from both sides. Gotta make sure I take my time. I believe that's negative 66. We're going to divide both sides by that negative 6. Remember, guys, that when you multiply or divide by a negative with an inequality, it switches the direction of the inequality and would be greater than or equal to 11. Another item I just want to mention is I'm a fan of flashcards. I think they're a really useful study tool. So as we go, I might suggest if a student is having trouble with inequalities, or we're about to talk about quadratic equations and factoring, maybe we could take a moment to create a flashcard for it, or at least take some notes. All right, so n is going to be greater than or equal to 11, and so we match it with D. So we're moving along. This is basically our warm-up, right? So I'll kind of skim through this, right? Just good kind of little bit of review, a little ordered pair there. Then we get into the main topic of today, which is the passport to advanced mathematics. This is a topic on the SAT. It involves a lot of Algebra 2. There might be some complex numbers in there. So here's an actual question from an SAT. They ask us, what are the solutions of the quadratic equation? All right, so one straightforward method is why don't we divide the whole equation by 4? Just simplifying our equation, right? So if I divide everybody by 4, why do I do that? Because it's helpful. It's helpful if the coefficient of the x squared term is 1. Again, it just simplifies things. This is part of my approach to mathematics. I think a lot of math teachers are this way, like to keep things simple because the math itself can become rather complex. So if we divide by that 4, we have x squared minus 2x minus 3 equals 0. And now we're back to factoring. All right, so we're looking for two integers that multiply to be -6 and add to be -2. Well, I know that 1 times -3 gives us -3, and 1 plus -3 gives us -2. All right, well, that would work. So we would use x plus 1 times x minus 3 equals 0. To solve this equation, it's the zero product property. Which essentially says 0 times anything is 0. All right, try to keep this tidy over here. So in essence, we could take x plus 1 and set that equal to 0, or we could take the x minus 3 and set that equal to 0. All right, just making sure we're good. So let's solve each equation individually. We have x equals -1, and we have x equals 3. So those are the solutions of the equation. What that means is when you plug in x equals -1 or x equals 3, the equation is equal to 0. So that would be B. Now, I'm going to go more into depth on this topic in about 5 minutes, right? But I usually just kind of open up with an SAT question so we know what it might look like. All right, and I'd ask you for any questions, make sure that we are understanding what we're doing, and then we'll keep going. So we have 4x squared minus 9 is equal to px plus 2 quantity times px minus 2 quantity. In the equation above, p and t are constants. Which of the following could be the value of p? All right, so this becomes a discussion of the difference of squares, right? So I might ask, who remembers how to factor a squared minus b squared? All right, that is the difference of squares. All right, this factors to a minus b times a plus b. Okay, so using that model, we have 4x squared minus 9. So let's take the square root of 4x squared, which is 2x, and then let's take the square root of 9, which is 3. Okay, I could also write that, maybe make it more, this might be more logical. I could say a squared is equal to 4x squared, and b squared is equal to 9. And so we have to take the square root. right? So I apologize if I'm getting a little convoluted there. In essence, A would be 2x and B would be 3. Probably could have done that a little bit more, a little bit cleaner, but A is 2x, B is 3. So then we would just put that in the formula, 2x minus 3 times 2x plus 3, all right? So again, we have the difference of squares, a squared minus b squared. We have to determine what a and b are. So if a squared is the 4x squared term, we would have to take the square root of both to get a. So a would be 2x, b squared equals 9. We take the square root of both of those, b would be 3, and then we just pop it into the formula. And what are they? Then we have to ask ourselves, what is the question asking us, right? So giving you a lot of information. This is also something that we will discuss in the lessons is, so first we have to read the question, a little bit of reading comprehension. Some of these questions are circuitous in their wording. So what is the question asking us? Then how do we solve it? What's our plan, right? And we have to make sure that we answer the question, right? What is the question really asking us? They just want the value of P. All right, well, P is the coefficient of X, so it's 2. We're done, all right? All right, let's see what else we got. All right, so then I might dive into a little bit of content, right? So we might talk about factoring, right? So how do we solve each equation by factoring? Well, these are fairly straightforward. It's really the zero product property that I mentioned before. In essence, v plus 5 would have to equal 0. So subtract 5 from both sides. V would be negative 5. And that's the solution. All right? Here, set each factor. Again, x minus 5 is a factor, as is x plus 4. So x minus 5 would equal 0. X plus 4 could equal 0. Solve them individually. I'm adding 5 to both sides here. X is 5. Here I'm going to subtract 4. So x is negative 4. Those are the solutions. I can also add to that a little bit. What do we mean by solutions? Well, graphically class, this is a quadratic. These are polynomials of degree 2, so they're quadratics. And when we look for the solutions, let me use black, we're basically looking for where does it cross the x-axis, which is where y equals 0, okay? This is, I think, important to understand. The x-axis is where y is equal to 0. So, for instance, number 1, I know we're using v, so let's humor me on this. Let's say v is the horizontal axis. At negative 5, it crosses the x-axis or the v-axis. Yeah, it turns out this is just a parabola whose vertex is sitting on the x-axis, okay? So just for comprehension, the solutions of these equations is where they cross the x-axis or the horizontal axis, okay? And that's really this topic here. I would reinforce the factoring. I'll do one more. Here, x minus 4 could equal 0, or 4x plus 1 could equal 0. Add 4 to both sides. Here, subtract 1 from both sides, and then divide by 4. Okay? So those are the x-intercepts, where it crosses the x-axis. Okay, so again, I don't like to rush. I would always make sure that my students are understanding. If that clicks, if that makes sense, we would move on. and we would talk about graphing polynomial expressions, which I alluded to a couple minutes ago. When you set the polynomial equal to 0 and solve for x, those are the zeros of the function. In other words, those solutions indicate where the graph is equal to 0 and crosses the x-axis. I think this is an important concept, and I think it's helpful for students to understand that. Excuse me. So then we might talk about factoring, right? So how do we factor? Again, these basic quadratics, what two numbers multiply to be that constant, that positive 6, and add to be this middle coefficient, the negative 5. And we would take some time. This one would be x minus 2 times x minus 3. Again, notice that the middle term is negative. So we're going to need one negative integer. In this case, we need 2. And we could talk about that. Since it's a positive 6, we need 2 negatives to get that positive 6, and then they would add to be the negative 5. All right, and I would, of course, slow down and make sure that the students are understanding. To multiply to be a negative 6, and add to be multiply to be a negative 7 and add to be positive 6. This middle term is positive. So actually, let me go with both options. This could be x plus 7 times x minus 1. It could also be x minus 7 times x plus 1. And we could have a little discussion there. Well, we could check our work. If we FOIL these out, this ends up as x squared. What is that? Minus, outer is minus x, inner is 7x, last is negative 7. I could also point this out. Maybe I should slow down there. We could talk about what foiling means. It's probably a good topic. Foiling refers to first, outer, inner, last. That's when we're multiplying binomials, right? We could unpack that for a couple minutes. Notice that this becomes x squared plus 6x minus 7, which is what we were trying to get. And please note here, this one would give us x squared plus x minus 7x minus 7. So this is x squared minus 6x minus 7. So that is not what we wanted. That gives us a negative 6 in the middle. And again, we can really just talk about how to factor properly. There's some difference of squares, and we can just make sure that we understand how to factor, because it's an important piece of this. From there, answering questions and so on, we might talk about the quadratic formula, which is very useful. The quadratic formula, this comes from, I could add that to the slide. This comes from ax squared plus bx plus c. That's a standard form. So these a, b's, and c's, they come from, a is the coefficient of the x squared term, b is the coefficient of the x term, c is the constant. We plug that in. I'm just going to kind of skim through this now because we'll get to the actual SAT, but we spend some time on the quadratic formula. It's very, very useful. Good tool to have in your toolbox when you're solving some of these equations. And then from there, then I give you a thumbs up, and then we get to some actual SAT. So then here's a question from, I think this is a College Board exam. What are the solutions to 3x squared plus 12x plus 6? Well, I'm going to just use the quadratic formula. So here, A is 3, B is 12, C is 6. Again, the quadratic formula is negative b plus or minus square root of b squared minus 4AC all over 2A. This is a good flashcard moment. A little test correction card. This is a good one to have on hand. So we plug this in. How about negative 12 plus or minus square root of b squared would be 12 squared, 12 squared, which is 144, minus 4 times 3 times 6, all over, I'll put it separately, but they're both over 2a, which is 2 times 3, okay? And this is x equals. Again, the quadratic formula helps us solve for x, the solutions where meaning these are the values of x when we plug them in, the equation is equal to 0. They're also the x-intercepts, which are also where the graph crosses the x-axis. All the above. So here, negative 12 over 6 would be negative 2, plus or minus. A little bit of math, 144 minus 4 times 3 times 6, what is that, 72? 1272. 144 minus 72 is 72 divided by 6. All right, we have to simplify our radical. Radical 72 is radical 9 times radical 8, which is 3 rad 8. Radical 8 can be reduced to, there's a radical 4 in there, which comes out as a 2, so that's 6 radical 2. We could also have a discussion there about how to simplify radicals. And just for my teaching style, this is how I teach. If we need to slow down on that, we can take a moment and talk about simplifying radicals. For instance, radical 8 is radical 4 times radical 2. Radical 4 is a whole 2, so that's 2 rad 2. And that comes out. So, again, any of this stuff can be broken down as we go. So, just to finish, x is negative 2 plus or minus, sorry, I gotta focus. That was 6 rad 2 over 6, which is negative 2 plus or minus rad 2, A. Okay? Any of these we could talk about. I can answer any questions. And then we can also do other types of questions. It doesn't have to be all these polynomials and whatnot, so we can do a couple of these. The line graphed in the XY plane below models the total cost in dollars for a cab ride, Y, in a certain city during non-peak hours based on the number of miles traveled, X. Okay, this is total cost of a cab ride. Always please check the vertical and horizontal axes. Vertical axis is cost in dollars. Horizontal is the distance traveled in miles. What are they asking us? According to the graph, what is the cost for each additional mile traveled in dollars of a cab ride? Could even highlight it or underline it. What is the cost for each additional mile traveled? That is slope. I might explain that. They're basically asking for slope there. All right. So slope is rise over run. So basically the change in cost over the change in distance. Again, that triangle is delta, means change. So what is the slope of this line? Well, as it goes up $1, or no, sorry, what's the cost of each additional mile? So 1 mile, so it goes from, say, there to there. Each one of these represents 1. The rise is what? It goes from 3 to 5. So isn't that just 2? The rise is $2. Yeah, just 5. 5 minus 3. over 1 minus 0. It's just 2. All right. Let's look at another graph. So this is the number of 3D movies released by year. Again, let's look at the axes. We have number of 3D movies released. We could even notice the numbering, the intervals. It's going by tens. The horizontal axis is in years. According to the line graph above, between which two consecutive years was there the greatest change in the number of 3D movies released? Okay, greatest change. So that means really slope, right? What's the steepest slope? It could be going up, which is a positive slope, or it could be down, which is a negative slope, but we're looking for steepness. 08, 09 looks possible. I could also, maybe at this point, I would start to mention some test taking strategies. One of which is using the answer choices. It's always good to check out the answer choices and eliminate ones that are not right. So 2003, 2004, it's not much of a change there. We're going to call this process of elimination. 08, 09 looks good. 9, 10, not so much. But once we get to 10 and 11, 2010, 2011, that I believe is steeper. So I would go with D there, okay, and eliminate B. So at this point, we talk about some strategies, process of elimination. Actually, this one I can teach you one other strategy, which is always good, which is basically picking numbers or plugging in values. So the expression 5x minus 2 over x plus 3 is equivalent to which of the following? You could do polynomial long division, all right? But just for today's lesson, I'm going to teach you how to plug in numbers. Here's the strategy. Stay away from 0 and 1. They have unusual properties and sometimes can be problematic. So how about x equals 2? Numbers like x equals 2, 3, 4, 10, 100. 100 is good for percents, but I might maybe teach you that another time. X is 2. Plug in x equals 2 into our expression. So 5 times 2 minus 2 over 2 plus 3. Simplify. 10 minus 2 is 8. 8/5. Box that answer in, please. Now, plug in the number you chose, which is x equals 2, into the answer choices. Which of the answer choices gives us 8/5? A would be, what is that, 3/3? It's not 8/5, so we can eliminate. 5 minus 2/3, we have to find common denominators. I believe it's 15/3 minus 2/3. It's not 8/5. I think it's, what, 13/3? C, I'm going to find a common denominator of 5. So it's 25/5 minus, I believe it's 2/5. That's 23/5. And then we get to D. I'm going to find a common denominator. This is 17 over 5. That is 8/5. That's our answer. Boom. That's called picking numbers. There's a little bit more to this strategy, which I might emphasize on another lesson. Sometimes two answers will work. In that case, we have to plug in a new number. We'd have to plug in, say, x equals 3, solve it again, and then only check the answers that worked, the two answers that worked, and at that point, one should work. It's a really good strategy. The other one, which I might talk about at some point, is plugging in the answer choices. We call that back solving. And we really just go from there. There are a number of different ways of solving SAT questions. My goal with my students is for you to understand the math, understand the concepts and how to do it, but then also utilize some of these strategies, picking numbers, plugging in the answers to save time, because we don't have a ton of time on the SAT and we want to save energy. So I try to do both with my students and kind of balance that out. So I hope that this has been helpful. And if you have any questions, I'd be happy to answer them. And I hope you have a very good day. So thank you very much.
Okay, so thanks for watching, and please remember to contact us at info@embracetutoring.com to set up any personalized private tutoring sessions you would like. Stay tuned for future videos, and best of luck with your studies. We definitely encourage you to visit our Instagram as well as TikTok pages if you have any questions along the way. Take care, guys. Best of luck with your studies.